Alright, so first thing we're going to be doing is covalent Lewis dot. So first we're going to start off with H2O, which is water, if you guys didn't know that, but it's H2O. So first we're going to have two hydrogens, so I already drew one, but we're going to have another one, and one oxygen. Then, like we're going to use our elemental, we're going to use this little graph here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 to represent our valence electrons. So we're going to move our valence electrons, so hydrogen has one valence electron. And one thing, while I'm drawing this real quick, is that hydrogen is only going to ever want 2 valence electrons. Oxygen has 6 valence electrons. So 6, we're going to go 1, 2, 3, 4, 5, 6. And there, oxygen has 6 of them. So what we have to do next is we have to connect these so that oxygen can have 8 and hydrogen can have 2. So we're going to have a line going from here, and we're not do arrows though, because arrows is technically not the right thing. And then from here. Alright, so now everyone's shared, because now they have 8 and now they have 2. So the fancy way to draw this would be to put oxygen right here, and have it being shared, a bond here with hydrogen, and a bond here with hydrogen. And that would look like this, because oxygen had 2 lone pairs from before, which are going to be these 2. Alright, next, I don't know what that is, next we're going to go on to CH4. So carbon is going to be over here, and it has 4 valence electrons. We're going to go draw carbon with its 4 valence electrons. Then we're going to move on to hydrogen, 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 another hydrogen. In case you didn't know, another hydrogen. Alright. And they all have 1 valence electron, so we can call them 1. So I'm going to draw that real quick. 1, 2, 3, 4. So we're going to move these over because this wants 8 and they only want 2. So we're going to scoot that all the way over here, all the way over here, and all the way, so on, so on, so on. And then eventually, all the hydrogens are going to have 2 valence electrons, and carbon is going to have 8. So that's how it works. And then we're going to go ahead and draw it the fancy way. So C, it's going to stretch over to 8, because that's H, because it's 1 bond. H, because it's 1 bond. H, because there's 1 bond. And H, because there's 1 bond. And because they're all sharing, because carbon doesn't have any lone pairs left, it's not going to show any there. So unlike oxygen, how it had 2, it doesn't have any over here. Alright, and then we can go ahead and move on to our pH3. So P is going to be phosphorus. We're going to go ahead and draw phosphorus. So phosphorus over here, we're going to find it on our periodic table, which is right here. And it's going to be in column 5. So we're going to give it 5. Yes, okay. 4, 5. All right. And then we have 3 hydrogen. So we can draw 1 hydrogen, 2 hydrogen, 3 hydrogen. And we see that it only has 1, again, like all the other ones, and have 1, 2, 3. Alright, and we can go ahead and spread our phosphorus all over here. So there we go. Hydrogen has 1, hydrogen another one, another one. So now all 3 hydrogens have 2 valence electrons, and phosphorus has 8. Then we can draw it the nice way. So phosphorus is going to look like this. Right in the middle, 1 bond with hydrogen, 1 here, here, and like this. So 3 hydrogen. And then phosphorus had 1 lone pair left over, which is going to be these 2. And we can go ahead and draw those right here. 1, 2. If you look at that, we pretty much use lines in order to connect them, and use our same old chart just to make sure that all the regular ones, except for hydrogen, because it only wants 2, have the amount that they want. And that's pretty much how you do covalent Lewis dot.